Right. Good afternoon. Yesterday, we spent close to an hour, 20 minutes, just looking at a high level how to solve a problem like this. Okay. So some of you might find very familiar. Okay. And I'll tell you what's the problem with questions like this. And I'll show you what is my expectation. Okay. What is my expectation? So some things that I'm going to show today, you might not know what is going on, but don't worry. Okay, remember, you are expected to do this after April the 10th. To be clear. Okay, so I'll show you what are my expectations, and not just what are my expectations. What are some of the assumptions that you have to what? Make? To be clear. Okay, and this is what I will expect from all of you. So if you look at this problem, right, the final goal, there are twofold. One is to determine the value of omega naught, and the other one is to determine the safety of factor. Can someone point to me what is the number one, or what information out there is missing? Anyone? What information is vital in this problem that's needed to calculate the safety of factor? Anyone? Come on, yes. Yeah, spot on. What is the value of the length? We only know from AB is L to BC is what? L over 2. If you don't know the magnitude of L, how are you going to determine the factor of safety? Yes or no? So what you can do? You are going to assume the value of what? L. In the solution that you propose, you have to tell Eugene, okay, you don't need to write Eugene, okay? I'm going to assume an L value that's equal to 2 meters. I'm going to assume the L value that's going to be what? 1.5 meters. Whatever L value you assume, the factor of safety will be different. Then come to your mind, how are we going to plot Mohs circle if we don't know L? All right? Mohs circle, you have to have stress value, normal stress value, and the x-axis, and the shear stress value on the y-axis. Right? So all this will start coming to your mind when you solve a problem like this. My solution in life, or my solution in solving problems is like this. Do not just stare at the problem. Work through it step by step. How many of you have been to Egypt? From far, far away, if you look at the Great Pyramids, what does it look like? A big pyramid. When you walk closer, what do you see? No. You realize it's this. It's made up of rectangular blocks to become a what? A pyramid. I.e., the walking part you have to proceed, you have to do. Are we clear? Don't stand down there. Procrastinate. So when this question came on the exam, a lot of students, what do? Procrastinate. The class average was 2 out of 10. Okay? I don't let it happen. I don't let it happen. So you walk, you move. Okay? Right. The figure shows an overhanging beam of W310 by 23.8 supporting a gradient distributed load. The material has a yield strength of 200 megapascal. Using point B together with the shear stress criteria, determine the magnitude of omega naught and the factor of safety. So the first thing that we're going to determine is we're going to determine our shear force at B and the moment at point B. This is what we're going to determine first. Okay. And next, I'm going to write the purpose is so that we can determine. So I'm going to follow the transformation over here. Okay, what you see over here. So what you see over here, this is our stress X. This is our stress Y. So from here, the purpose is we're going to do this. I beg your pardon. So can you put moment about Z at point B and Vy, the shear force in Y at point B, please. Okay. So the purpose for us to do this so that we can determine what is our stress X, normal stress in the X direction, where you have mz at point B over izz multiplied by y. Okay, and the next formula that we're going to apply, so by looking at the shear, we are going to determine the shear xy at point B, and this will be equal to Vy at point B over Ixx Qx divided by T. Okay. So the only thing that you are not sure is Qx is the first moment of area about the x-axis. That is the purpose. Okay. So from here, once you determine these values, then we can construct the stresses acting on the element. Based on yesterday's lecture, you all will have an impression what is going on. We clear, right? You have an impression what is going on. So what we are going to construct now is an element that we need to find what is our I'm going to assume it to be tension. Okay, I don't know yet. Okay, now whether is it compression or tension, we don't know yet. So we know that we're going to determine this stress X, and we are going to determine our shear XY. Okay. So I'm going to stop here, and I'm going to show you the stages of steps that we have to go through. Again, this is just part of the question. And if you look at the number of topics involved relative to 2PO4, is 3 topics. Yes or no? One topic is stress X value. That is under what? Symmetry bending. Do you all have any idea what we mean by symmetry bending and asymmetry bending? Anyone, please? What is the difference? Yes, ma'am. Anyone else? Yes. Why do both of you have that impression? Or why does all of you have that impression? You all agree, yes or no? Symmetry and asymmetry, yes or no? Nothing to do with loading, nothing to do with geometry. It's all based on stress field. Nothing to do, I repeat again, nothing to do if the left-hand side and the right-hand side of the load are the same, the structure, the geometry are the same. No, nothing. It's all dependent on the stress distribution of the structure. Are we clear? Okay, don't be like me when I was young. You take it as English, literally. It's not. Okay, it depends on the stress field. I will teach this on week 3 or week 4. Okay, so don't worry about it. Yeah. Right. So now we are going to, first thing we're going to do, we are going to do what? We are going to construct, we are going to determine our shear force and bending moment diagram. So the first thing we're going to do is we're going to construct our FBFBD. Any idea? Yes, it stands for freaking big free body diagram. Okay, so by looking at the geometry, I'm going to take the geometry so it's easier for me. Okay, don't worry about this part yet. So if you look at the structure, right, you have point A, point B, and point C. Okay, so this is my point A. And over here, this is my point B. Why we are going to do this? Because we need to find the reaction at point A and point B. Okay. Now let me ask you a question. What is the purpose of finding the reaction? Dr. Koshi taught your integration method, you know. Yeah? With integration method, why do you need no point and point? Yes. Yeah, you want to know what is the magnitude at point A and at where? At point B. But what is the purpose mathematically? If you know the reaction at point A and point B. Yes. Partly right. Okay. Why you want the reaction at point A and at point B? Because those are known as your what? Boundary what? Boundary condition. Are we clear? Okay, don't just go through a motion, I'm going to do this, and you don't know why. No, we have to know why. So we have to find the reaction at point A and point B, because these will serve as boundary. Come on, you didn't write properly. I'm still nervous with writing. I don't know why. This will serve as what? Boundary condition. Yes or no? Okay. Right. So it's obvious. Okay. It's very obvious that I'm going to assume you have AY over here, and we're going to assume that we have BY over there. And the next thing that we are going to calculate, or we are going to determine, is we are going to have a load over here. And this load over here, we have our equivalent load. Does it look familiar? And the equivalent load is half omega naught multiplied by L. If this said, the equivalent load will have a distance from here to here, which is equal to what? Anyone? 2L over 3. Agree or disagree? Right? So just to help you recap, if we have a triangular distributed load, if you have a triangular distributed load, okay, so now what does this mean? If you see a symbol like this, what does it mean? So mathematically, if we were to sketch this is x and this is omega naught, this is actually what it means. Yes or no? So if you look on the axis down here, our x-axis is x, our vertical axis is omega. And the equation of this line, and I'm going to make this distance from here to here to be L. What we have is what? Omega as a function of x is equal to omega naught Lx. Right? So